So good morning, everyone, and thank you for making time out to join this webinar on using mobile big data analytics to combat global challenges, including COVID-19. We've set up this webinar to discuss big data and the privacy implications, especially within the current realities that we live in, with governments trying to combat COVID-19 and the spread of the virus in their countries. There's a lot of reliance on big data for solutions to help in the fight. And we've taken this initiative to share some insights from the mobile industry perspective as to how best to apply the concept of big data in this fight. Next slide. I suppose I've already provided an introduction. My name is Kamal Kamal. I'm this Sub-Saharan Africa policy team. I'm based out of Nigeria, and I cover a lot of the markets in Sub-Saharan Africa as far as it has to do with policy-related issues. I have a bunch of colleagues as well dialing in from the London office, and they'll be introducing themselves whilst presentations are being made. So at the GSMA, one of the main incentives for us for associating ourselves with big data and artificial intelligence is to do with the United Nations Sustainable Development Goals. In March 2016, the mobile industry was the first sector to commit to accelerating impact against the UN's 17 Sustainable Development Goals. The mobile industry accelerates and scales mobile initiatives to tackle the most critical challenges facing our planet. AI for Impact, or artificial intelligence for impact, is the GSMA in-house initiative, which is developing global partnerships to accelerate action and achieve impact that is in alignment with the UN Sustainable Development Goals. This GSMA initiative, guided by a task force of 21 mobile operators and an advisory panel of 12 UN agencies and partners, defines the technical, commercial, and ecosystem requirements to deliver viable, data-driven products and services that adhere to the principles of privacy and ethics. At the national level, GSMA supports real-world implementations, replicating proven models, and delivering market-shaping campaigns to unlock demand and address barriers. Next slide, please, Charlie. Sorry, Rob. So, what is big data? I think that's a very good place to start, because there's a lot of misconceptions and definitions and different understandings that exist out there as to what the term is. What exactly is big data? It's a relatively new term with many somewhat vague definitions, and hopefully over the next few minutes we'll try to present what it is and the fundamental principles that are associated with it. We'll also try to explain the key properties of big data and what makes it different from traditional data sources. So let's start by describing the key features of big data. Next slide, please. Critically, first of all, big data is natively digital. It doesn't need to be recorded or encoded or converted. It is ready to be fed into an analytics pipeline from the point of collection. Many modern systems produce natively digital data. So I have put up 3 examples here: mobile networks and the way they operate daily, the banking system with all of the transactions that happen on a daily basis, and generally all of the activity that happens on the internet. All of this can be classed as data that is natively digital. Next slide, please. So reference to big data generally involves large data quantities from multiple and diverse data sources. So this describes maybe the large volume of data that comes, and the fact that it comes from a variety of sources gives it a characteristic of having a lot of variety. It is created in near real time, which speaks to the velocity at which it is being produced. The use of data processing techniques to analyze the data, identify correlations, and generate potentially unexpected insights that might have a predictive quality. And hopefully over the next few slides, we'll delve a little bit deeper into what we term as the 4 V's of big data. Next slide, please. So the first V, volume. As the name implies, big data is big. It takes up a lot of space on disk. It updates and expands rapidly. And this means that powerful computing resources and specialized software and techniques are required to process and analyze it. Mobile networks commonly process billions of events per day, and possess the infrastructure to manage and organize this amount of traffic and the data it generates. Similarly, the volumes of data generated, for instance, as trading proceeds on the stock exchange or the Google search activities on the internet, it provides a perspective of what big data is. Next slide, please. Secondly, and as I mentioned earlier, big data combines different types of data with different structures and formats. This needs to be managed separately with the ability to combine them when appropriate. So within the context of mobile networks, for instance, there are broadly three types of data. So there's event data, which provides time-stamped locations of specific customers. There's network topology, which gives geographical locations. And then there's customer profile data, which provides an enriched picture of the types of people using the network. Each of these has different natural structures and processing systems. Events, they sit in event stores or data streaming platforms with especially high write capabilities. So for example, high performance SQL or modern NoSQL database like Cassandra, Kafka, Storm, etc. In terms of network topology, this data typically has strong geographical components, and processing will therefore typically require some sort of GIS capabilities. So you need things like, for example, ArcGIS or PostGIS or QGIS, etc. Then there's the customer data, which is usually tabular in form, and it's relatively static. It doesn't update very often. It's not updated really often, and it sits well within a normal SQL database. Next slide, please. So it's possible to find many answers in big data, but it's very, very critical to ask the right questions in the first instance. The complexity of the systems that generate big data can hide surprising variations, noise, or sources of bias or error. So for example, in the case of mobile, when we ask the data, how many people made calls in region X on day one? What we are really asking is, how many SIM cards made calls? So SIMs might be shared between multiple users, and individuals might have multiple SIMs with different carriers. So this basically, I'm trying to describe a little bit of the complexity around why there is a need to ask the exact right questions here. So additionally, there might also be biases in the customer base versus the wider population. Network issues might lead to dropped or duplicated traffic. Reassigned cell IDs or MSISDNs can create misleading signals. Dwelling on the edge of two cell coverage areas can lead to handover events that appear to show oscillatory movement, for instance. So all of these sources of noise need to be understood, they need to be quantified and mitigated for the data to be used safely and reliably. Next slide, please. So finally, big data is organic, and this is absolutely key. It is passively generated by normal natural behaviors. It is not recorded on requests. You don't need to click any magic buttons to make it happen. There's usually no explicit intention of even collecting the data in the first instance when it is being generated. So what this does is it allows for unique insights into otherwise invisible patterns without the individual biases associated with deliberate data collection from, for example, surveys. Next slide, please. So now, in addressing development problems with the support of mobile big data, there are a wide range of development and humanitarian challenges that could benefit from insight derived from big data. In fact, many of the UN's SDGs can be informed by the granular population density, population movement. Apologies, I'm not sure if you can hear my inbox continuously alerting, but I'll just close it now. So as I was saying, many of the UN SDGs can be informed by the granular population density, population movement information, and associated data that can be extracted from mobile networks. So the table on the screen right now shows a little bit of a framework that simplifies the 17 SDGs by grouping them into 5 big themes. So themes for which mobile big data can play a role. These themes also relate to policy areas and can also help to focus discussions with government ministries responsible for particular departments and SDGs, or to also focus on priorities for a country, for example. So under each theme, there are a number of sub-theme boxes that illustrate specific types of use case for mobile big data. Each of the names on the box, for example, it can crime prevention, for instance, school connectivity, providing safe water and climate migration. Excuse me, please. So for each of these, there are real projects and implementations of mobile big data, and for which studies have been publicly published. They each address a genuine problem faced in a country or a city. The range of use cases shown in the framework is also broad. It includes long-term infrastructure planning applications, for example, where to site schools or hospitals to best serve the population, how to plan a transport network, for instance. It also includes much shorter-term applications, for example, how to understand where people are located after a disaster so that rapid evacuation can be enabled, or to ensure emergency supplies are directed exactly where they are required, for instance. So this is obviously not an exhaustive list of use cases for mobile big data. New applications are constantly and already being explored, and new models and predictions are being created using the richness of the data. Using mobile big data to create insight and solve one problem is always likely to generate many other ideas about how it can be applied to different challenges. So where census data, bespoke surveys, or expensive monitoring equipment is currently deployed to understand the distribution and movement of groups of people, for example, it's an area where mobile big data can play a role. So at this point, I'll hand off to Charlie. Charlie is the technical lead for big data at GSMA, and he'll be providing a little bit of an in-depth technical perspective into big data. Charlie?
Thank you. So Kamal has given us a great introduction to what we mean by mobile big data and how it can be applied to solve societal problems at the high level. Of course, we have a great example of a societal problem right now. We're living in the midst of a global pandemic, and operators all over the world are working with their governments to try and help them make better decisions and improve the responses to this crisis that we've seen. As you can see from this map, of course, we know that the global pandemic is global, but the response is also global. And we've been keeping track of as many projects as we can with many of our operator contacts. And so I'm going to talk a bit about the types of use case that we're seeing and the kinds of decisions that can be supported by using aggregate mobile big data of the kind that Kamal described. Next slide, please. Thanks. So this curve is supposed to represent the rough course of an epidemic or a pandemic in terms of the severity. I think everyone is probably more familiar with terms like exponential growth and peak and curve, possibly than they ever wanted to be, and you're interested in that kind of thing. But I hope that's clear. So we can, of course, governments have to make really critical decisions at every point on this curve, but we can split it into roughly 3 consecutive stages. So in the early stages, the number and the rate of new infections is increasing rapidly, and the focus is on preparation. So the main activities are around planning, and the key watchwords are prepare your resources, equipment, hospital capacity, protect the population, and delay, which means avoid a very steep curve which could overwhelm the health systems. There might not be anything that we can do about the number of people that get infected until there's a vaccine at least, and who knows how long that will be, but at least we can avoid them all getting infected at once. And the top level question is, how might the disease spread? How quickly is it spreading? What is the average infection rate? What kind of patterns of infection are we likely to see amongst the population and across the country or the region? How fast will it move? How many concurrent infections are we likely to have? And what can we learn about other countries' experiences? And knowledge and information sharing is really critical. And then moving forward towards the peak, the focus shifts towards what measures should be taken and when. And there's been a lot of controversy over exactly the right moment to implement social distancing measures. Certainly our government in the UK has faced a lot of criticism over those decisions, as I suspect they would have whatever they'd done. But most of the world's population has seen some form of lockdown, and the governments need to decide exactly what this should look like. Which industries should be shut down or kept running? Should schools stay open or close? Should this apply to certain geographical regions or economic regions? Or are there other measures like curfews or partial distancing measures that could be used? Mobile data can support these decisions too. And then moving forward, once the peak has passed, countries will start to turn their attention to recovering from this major societal and economic shock. And that, of course, has to be done responsibly, and it's an extremely complex puzzle to solve, piecing back an entire system. Which operations should be restarted and when, which areas are safe and which areas are not safe and need to maintain measures, and also monitoring which industries are recovering well and which need more support. And then throughout, there are questions about observing, monitoring, assessing. Whichever measures have been implemented, are they working and how well are they working? Are some sectors of the population complying better than others or faring better than others? And does messaging need to be strengthened or targeted? Are the predictions that we've made correct? And are our resource allocations sufficient? Can we improve our logistical setup? Next slide, please. So how is mobile big data processed to create these kinds of insights and support the kind of decisions that I just spoke about? This diagram illustrates the generic process of taking mobile data and adding value to it and producing insights that support these kinds of decisions. We don't have time to go into it in huge detail, I'm afraid, but hopefully there will be a capacity building course that can go into it in a bit more detail. But in brief, Kamal mentioned the three types of MNO data that provide the foundation for these things. And we have customer data, which is information about the customers themselves, which is fairly static, and what exactly that contains varies, but it's used for customer relationship management. Then there's event data, which is about interactions between customers and the network, and that's very fast moving, updates very rapidly. And the events then link a customer, or a SIM card rather, to a cell tower or base station at a point in time, which is, of course, that's the key principle that underlies location and mobility data insights. And then we have network data, which is data about the network itself. So the locations of the towers, whether they're functioning or not, and how much activity is running through each part of the network. And so those are combined in the processing stage, and a lot of expert care and attention is given to produce accurate and reliable results. Quality assurance is performed at this stage. There's lots of correcting and controlling for potential sources of bias and extrapolating to represent the population as accurately as possible. And operators are very good at these things. They generate the data, they know their own systems very well. So they perform these cleansing, filtering, and validating functions. And then we move on to analytics, where the cleansed and processed data is combined with other data sources and subjected to analysis, depending on the research questions or the specific objectives. This is obviously very dependent on what the actual objectives are, the specifics of the project and the desired outcomes. But it very likely will involve data from other non-mobile sources, like, for example, satellite data or survey data or infrastructure maps. And of course, the application of specialized tools or techniques like GIS, machine learning, statistical analysis, as Kamal mentioned briefly before. And that might be done by operators, or it might be done in collaboration with other agencies who have that kind of capacity. And then finally, the analytical insights are packaged in a way that is meaningful and usable by the decision makers. So that could be a visualization or a dashboard. It could be one-off. It could be ongoing and updated regularly. It could be visual or quantitative. There are lots of requirements there. And that part is an important tailoring to whatever the requirements of the end user are. Next slide, please. Thanks. So there are 4 high-level categories of aggregated location and mobility data that we've seen applied to COVID-19, to the crisis. Those are dynamic population maps. So these represent the number of people present in each region of an area at a specific time. And they're updated regularly, so they respond to real-time fluctuations in those populations. So this is really useful for resource planning or identifying gatherings or potential transmission hotspots. And they can help to facilitate decisions about recovery, so identifying maybe which industries or areas might contribute to increased transmission. Then OD matrices. The OD here stands for origin destination. So these represent the travel between pairs of locations or regions. So that might be given as there are lots of ways to calculate them. I won't go into too much detail there. But each method has a different strength and weakness. But they're all useful for various things. They're used for modeling how an infection is likely to spread, monitoring movements between regions depending on, say, border control or lockdown implementations, and understanding displacement over a longer term. So have people moved from an urban environment to a more rural one, for example, or vice versa? Have they been forced away from their usual places of residence? And then also monitoring recovery in the form of perhaps the reverse of that, or the return to what might be considered a normal movement pattern. Then mobility measures focus on how much people are moving around in a specific area, so not between areas, but in a single area. And again, this can be calculated in a number of different ways. For example, how many journeys people are taking away from home, and many other examples. And these are useful for measuring the level of obedience, the compliance to movement restrictions in particular. And again, figuring out how that might contribute to ongoing transmission. And then finally, the amount of network activity that passes through a particular portion of the network can be very useful. And that can be segmented by customer type or by region or by the service that a particular call is made to. And that can be useful perhaps for monitoring public concern, for proxying the demand on a health service, or as a measure of economic activity in some areas with careful calibration.
Okay, we move on to the next presenter. Jade will be presenting policy and privacy considerations from Jade is with the GSMA and Consumer Policy Program within the GSMA. Jade.
Hi, thank you, Kamal. The first slide, please. So, the GSMA has really been focused on issues of privacy and security, and really just how policy and best practices can build and sustain trust. We've been focused on this for a number of years, and we developed privacy principles for the mobile industry several years ago. But recently, as many of you may be aware, there's been a growth of new and revised data protection laws around the world. And many of our members are looking at these proposed laws and new laws and trying to figure out how they should comment to make the law future-proof and to help it enable innovation while also protecting consumers. Additionally, we do a lot of engagement with governments to help answer their questions about privacy issues with mobile operators. And we thought that if we developed a tool describing our ideal privacy laws, that this would be helpful for governments as well. So building on all of the work that we've done in the policy and regulatory space on privacy, we developed this Smart Data Privacy Laws report last summer. And the report focuses on these main elements of a smart data privacy law. For example, that the law should really be based on accountability, in that organizations should be held accountable for doing what they say that they're going to do at a high level. They should be able to demonstrate that they are accountable to regulators when asked. These laws should also be based on principles rather than very specific requirements that are based on specific technologies. That's not a future-proof approach. Instead, it should be based on principles like data minimization, for example. Only as much data that's needed should be used for a particular project, and then it should be deleted afterwards. That's an example of a principle which requires an assessment of risk by the company, by the organization. And that's a huge part of this for us, that these laws should force organizations to think through the risks associated with processing, to mitigate those risks, and to ensure that the continuous operation of a system or a service is consistently thinking about privacy, how data is used. And at a high level, we call that privacy by design. Additionally, we believe these laws should be horizontal, in that they should cover all data processing operations. It becomes less efficient to have separate regulations for separate sectors, especially with the way that sectors are converging now. Increasingly, it's difficult to have separate sectoral regulations in some space, particularly telecoms. It is better to have a horizontal approach. So that report is online in multiple languages, and you can check that out. Move to the next slide, please. Next, oh, there it is. Okay. So in the context of our AI for Impact program, the GSMA has always been, again, mindful of sustaining consumer trust and also aware that there are various policies, regulations that we should encourage operators to abide by. Now, in the AI for Impact program, the GSMA itself is not holding any data, no aggregated, anonymized data. That's not what we're about. We are acting as an accelerator to try to get mobile operators scaled up to offer big data analytics in a privacy protective way. So we established a code of conduct, which establishes requirements for operators in the privacy, security, and access control space. So for trials of big data that fall under our AI for Impact program, that code of conduct applies. And that is in addition to a requirement to abide by any relevant local telecommunications regulations, privacy regulations, or security requirements. So we try to go above and beyond and encourage operators to also go above and beyond to be very clear about how data is used. And this is even true in the context of aggregated and anonymized data that the operators are processing. We still want to make sure that that data is protected, that it's used ethically, and that there's a consistent process to think through the risks of using that data. And by risks, we could also mean, for example, risks to a particular group where you still can't identify any of the underlying individuals, but you may be able to infer something from the group. So these are just things that we would like people participating in AI for Impact to keep at the front of their minds. Move to the next slide, please. In the context of COVID, I think we've all seen the news about contact tracing apps. For example, the recent announcement by Google and Apple to enable Bluetooth proximity apps using their technology. We've also seen GPS discussed. Now, mobile operators are not necessarily in that space. We are quite firmly in the aggregated and anonymized data space, as Drew and Charlie described. But there are still privacy issues in this area, and that drove us to create with our members new privacy guidelines for COVID-19. At a high level, again, this is about sustaining trust, and we maintain that any use of data, either identifiable data in some exceptional cases based on necessary and proportionate legal orders, and also aggregated and anonymized data, which is far more common. The use of any of that data from mobile operators needs to be lawful. It needs to be transparent. So people should know that the data is being used, if their data is being used, and it should be time-bound. Any data that is analyzed in the context of COVID-19 should not be used for other additional purposes, and it should not be used after the pandemic is hopefully one day declared over, unless consumers, for example, are given precise notification that the data will be used for research beyond the pandemic being declared over. But the idea is you have to tell the consumers, you have to be forthright and upfront about how that data is being used and establish some time frame for the use of that data. Additionally, our guidelines talk about, in more detail, how governments should also be treating the data, because even with that anonymized and aggregated data, again, there can be some risks and security risks, access control risks. So we list a number of principles, again, that it should be lawful, transparent, and time-bound, but also that, again, this is linked to transparency, that the purposes of the data collection are set out and that they are limited to what has been described to consumers. So if you're collecting data for one reason, you can't then use that data for another governmental function. You certainly can't try to re-identify that data somehow using a third-party data set. Ideally, that shouldn't be possible anyway, but we try to prohibit the idea of even attempting that. Access controls should be put in place. We usually encourage audits to audit logs to make sure that you can tell who is accessing data and control that access to data. Again, even with anonymized aggregated data. And then accountability, that any recipient of mobile data, even if it is a graph or a heat map like Ju was showing, they need to be accountable for how they use that. And sometimes it's difficult to build that relationship between the private sector and the public sector to ensure accountability. But I think we all agree that for governments and the private sector, trust is critical. So it's important to memorialize agreements, for example, through letters or other public statements so that everyone is on the same page about how that is being used and what the strategy is for winding down the use of that data. If you could go to the next slide. So the next point here is on cross-border data flows, which is something that I think in normal circumstances is an important thing to mention for the overall data economy. Cross-border data flows are critical to the function of the data economy at this point. I think we've all seen that in the context of COVID, that in some cases, just for one webinar to work, you might have a cloud platform based in one country and a polling application that is based in another country, and content that's coming from another country. I mean, just for simple operations, you can see that cross-border data flows are critical. And for mobile operators, this is critical as well, because they want to be able to combine data from different countries without facing barriers to cross-border data flows. And again, under normal circumstances, this is really critical for seeing how the network is operating on the whole. But if we think back to the map that Ju was showing, if you have barriers to cross-border data flows, then you might not even be able to get that picture of what's happening across your regional footprint or your international footprint. So this also causes impediments for mobile data used in the public health context or in any emergency context, because you may not be able to get that full picture of the events across the network, which are aggregated and anonymized. There are some license obligations, for example, that make it difficult to transfer data. It's unclear if anonymized data can be transferred out of a country. Or there's a specific prohibition to transferring data because of national security aims. And while many of these public policy objectives are valid, we think that there are ways that they can be addressed through different solutions, such as encryption and other tools. And we have a report actually called cross-border data flows, realizing benefits and removing barriers. And that goes through a number of the justifications for putting cross-border data flow restrictions in place, and talks about how the restrictions can be removed if certain other controls are put in place instead. So if you're interested in this topic, I recommend taking a look at that. And as I said, there are ramifications on the broader data economy, but there are definitely specific ramifications in the context of our AI for Impact program and on the use of mobile data for these critical crises situations.